All right, here's part B. So we left off saying that the sine of B equals what? So now up here at angle B, we'll double this one. Okay, what's the sine? It's opposite over hypotenuse again, so it's what? It's 5 over 13. The cosine is adjacent, which is 12 this time, right? Because on angle B, the adjacent is 12 over 13 over the hypotenuse. And the tangent is opposite over adjacent, so it's 5 over 12. Now look at the relationship between these. Look at sine of A. It's 12 over 13. Do you see anything else that's 12 over 13? It's the cosine of B. So what's true about A and B? On a right triangle, give me a geometry word that's true about angles A and B. They're complementary angles, okay? Complementary angles because they add up to 90 degrees. Okay, that's always true about the other two angles on a right triangle. Would you agree with that? Mm-hmm. Okay, so look, the sine of one angle is the same, okay, as the what? The cosine of its, let's get fancy, of its, no, what's the word? Complement, right, of its complement, okay? So the sine of one angle is the same as the cosine of the complement of that angle, okay? So if I knew what the sine of 27, let's do an easier one, so I don't have to do the math in my head. What the sine of 30, okay, the sine of 30 would be the same thing as the cosine of 60. Does that make sense? Okay, that's kind of cool, isn't it? Look at the tangent, though. Like the sine of 30 is the same thing as the cosine of 60. Go ahead and do it on the calculator, and you'll see it's true. All right? So look, same thing here. Look, the cosine of A is the same thing as the sine of B, isn't it? 5 over 13, 5 over 13. Look at the tangent, though. All right? Tangent and tangent. The tangent of one angle is going to be what? It's going to be the reciprocal of the tangent of the other angle. Okay? Well, of its complementary angle. Right. Does that make sense? Okay? What? It doesn't make sense? The tangent of one angle is just the inverse of the tangent of the other angle. Look, this is 12 over 5, and this is 5 over 12. They're inverses of each other, right? Yeah? Okay. All right, so there you go.
The sine of 30 is equal to the cosine of 60?
Yeah, sine of 30. What? You have to have it on degrees. Your calculator's in radians. I'll show you real quick. This is a common problem with graphing calculators. Let me put this in the screen because it only shows up what's in the... See, getting fancy, aren't I? If I can... Oops, stink. Let's try to grab the thing. Okay. Make it a little smaller, get it to fit. Yeah. Yeah, you got to put it... you got to turn it on. Turn it on. Yep. It's just like a regular graphing calculator. Pretty cool. Download it for free. Yep. I forget where, but...
Oh, you can download it for free?
Yeah, you download it for free on your computer. Oh, you go to mode, watch. You go to mode and it gives you all this stuff. Now, I changed it. It was on radians, okay, but you have to make sure it's on degrees. For some reason, it defaults. Like if you turn it off or something, not just turn it off, but like if you take the batteries out or something, I think the default is on radians, which kind of makes sense because when you're first learning how to do these things, you do it in degrees, but when you get into pre-calc and to calculus, then they start doing a lot of things in radians. In this chapter, well, we're going to get to that. We'll do radians in this chapter, okay? But for the most part, this year, we'll stick with degrees, but we will show you how to change it to radians in either this chapter or the next, probably this chapter. Okay? It is. It's just another way to measure an angle and that kind of thing. But we'll talk about it. I'm not going to deal with it right now. All right? So just make sure that it is in degrees. Now, if you have just a regular scientific calculator, then it usually defaults to degrees. There's a DRG button. Press it. Press the DRG button. And if you keep, you'll see a RAD and a GRAD. You keep pressing it. Just keep pressing it until you see degrees. But if you turn it on and off, it'll automatically default to degrees. So anyway.
Should I have it in degrees?
Yeah, always having degrees on this, right? We're not going to be doing, we're not going to be using the radians. In pre-calc, you may use that, but for right now, we're not. Watch this. Now I can change to pretty colors too. Okay. I'm going to try to keep everything on this little slate right here. Let's do this. Let's actually solve for angle A. Okay, we said at the beginning they're just going to say find the sine of angle A, cosine of A, tangent of A. But this time I actually want to find out what angle A is actually equal to, what the actual measurement of that angle is. Okay, and we use either one of these. Look, we got all three of them. Okay, if let's just use that one, okay? It doesn't really matter. Let's just use that. Now, do you remember what we do on the calculator for this?
Yeah.
If I wanted to solve for A, what do? I have to get rid of the sine. Well, the sine is not something that I can divide by. It's not a variable. It's not a number. I can't divide by the sine, but I can do what? I can take the... Yeah, but give me a word. Take the... Say it. Inverse is the word I'm looking for. Take the inverse of the sine. Now, we'll talk about that. Now, he's not... He is talking about something that it does exist. We just haven't talked about it just yet, okay? But watch what we're going to do. I could take the inverse of the sine. If you remember back in geometry, I think, or not, I don't know. Did you guys do this? To the negative power? Anything to the negative power? You never did this?
Negative. We did it this year.
Well, yeah, we did it this year, didn't we? Yeah. Sure, it's 1 over 5, right? Because you flip it and you change the sign of the exponent. Yeah, we did this year. 5 to the negative first, right here. So it's 1 over 5 to the first, or 1 over 5. So taking something to the negative first power does what to it? It makes it the, give me the word, it makes it the inverse, right? It makes it the inverse. So watch what we're going to do. This should make sense. If you look on your calculator, you're going to see this. Watch, you're going to see sine to the negative first. What does that mean? Give me the word. Inverse. Inverse is the word I'm trying to get you to think of. It's the inverse. So watch. The inverse sine, actually I should have done this. I should have said angle A equals the inverse sine of 12 over 13. See that? See, 12 over 13 was by itself, but what did I do? I took this sine, moved it from one side, put it on the other side. But if I move it to the other side, I have to do the what? The inverse relationship, don't I? So how do I do the inverse of the sine? Sine to the negative first. You see that button on your calculator? It says sine to the negative first. Punch that in there, and we'll do it on the graphing calculator so you can see it. Just move this over. Yeah, you got to do the second function, okay? So on a graphing calculator, you do it right in order. You go second function, sine, that's the sine, right? Okay, and then you just put 12 over 13. 12 divided by 13. You could close the parentheses if you want. I just kind of like to do that, but you don't have to. Then you hit enter, and then there it is. It's 67 degrees. So if, let's get back on here. So, was it point what? 67.38. So we'll just keep it to the nearest, degree. So it's 67 degrees, and that's how you find that angle. Now that doesn't look like a 67-degree angle because we didn't draw this very to scale at all, but that would be 67 degrees. Now you could find this one, but how would you do that? You could do it really easily. Take it away from 90, all right? That's one way to do it, but let's do it another way. Let's use one of these B ones just to see what it should be. Now what should it be if I take that away from 90? Are you guys paying attention? Oh, okay. Oh, you saw it already, didn't you?
No,
Okay.
I thought you were just explaining it. I didn't know you told us to change all this.
Yeah, that was the whole reason. So watch. You could just take it. So what's 90 minus 67? That's what, 23? All right, so let's try one of these. You can try any. You can use sine, cosine, and tangent because we know all three of them, don't we? Which one do you want to use? We already used sine. Let's go crazy. Let's use the tangent, all right? So let's solve for angle B by doing the tangent. So let's go inverse tangent of 5 over 12. Now you don't necessarily have to write this, so you could go right from here and put it in your calculator. I just kind of like to write it like this because it shows you what B is actually equal to and what buttons to push in. And what'd you get for that? 22.6. 22.6, which rounds to what? 23 degrees, just like we said it should be, right?
So what happens if,
So that works out.
Happens if, like, rounding, you'll be like a degree off?
Yeah, the rounding would be different. So what I would do,
Find one.
on a test or something like that, if you put, if it actually rounded up or, and you put 24, now it would be nice if you round to the nearest degree that they all add up to 180. I mean, they should do that, okay? So I wouldn't be all that particular on that, okay? But the easiest way is just to take it away from 90, but it does show you that you can use any of these. I could have used the cosine or the sine with B, and I still would get the same exact thing. You can try it. It only takes you a few seconds to try it on the calculator and see, all right? All right, so that's just a little bit of trig, all right? Do you remember it? Is it coming back a little bit? All right. We'll do a little more tomorrow. It's Wednesday. I'm not going to give you homework tonight, so we'll finish it up tomorrow. I'll give you an assignment tomorrow, and we'll see how that goes. Now, you have that. Actually, let me turn this off. Say bye, everybody.
Yeah.